Okay, let's just jump right in. What if I told you that you could create a literally limitless supply of perfect AI training data just by describing what you need in a single sentence? I know, it sounds like something out of science fiction, right? But it's not. It's a real technology that could completely change how we build AI, and today we're going to break down exactly how it all works.
Seriously, just think about that for a second. No more hunting for data sets, no more of that painstaking manual collection. You just describe what your model needs to learn, and poof, the data just appears. That's the incredibly powerful idea we're diving into right now.
Now, to really get why this is such a huge deal, we've got to take a step back and remember the massive problem it solves. For anyone who's ever tried to build anything in AI, the single biggest bottleneck has always been the same thing: getting your hands on enough high-quality data. I mean, for years, the process was just brutal. Let's say you want to teach an AI to spot a specific valve in a factory, right? Well, you'd have to physically go there, snap thousands of photos from every single angle in all kinds of different lighting conditions, and then pay someone to sit there and manually draw little boxes around every single one of those valves. It's incredibly slow, it's super expensive, and honestly, it's been a massive barrier to progress for a long time. Now, to be fair, we have seen some progress. We moved on from manual photos to really powerful tools like NVIDIA Omniverse, which is fantastic for creating synthetic data in, controlled 3D scenes. But here's the catch. The real world isn't a clean 3D model. What about a chaotic city street or a super messy workshop? That's where those older methods just kind of fall short. And it's exactly that gap where generative AI is now stepping in as a total game changer. All right, so what is this tool at the heart of the revolution? Well, it's called NVIDIA Cosmos Predict, and it's a generative AI model that was built from the ground up to solve this one very specific, very important problem. So you might be asking, what makes Cosmos Predict different from all the other image generators out there? Well, it's what it was trained on. We're talking millions of hours of curated videos, mostly from the worlds of robotics and self-driving cars. And what that means is it has this incredibly deep understanding of physics, of how objects are supposed to interact and the consequences of actions. And that right there is absolutely critical for creating training data that's actually useful. And this is such a crucial distinction to make. A general AI video model may create something that looks absolutely beautiful, but it's often inconsistent. Think of it like a movie set. It looks good, but it's not real. Cosmos Predict, on the other hand, creates something that is useful. The output is controllable, it's consistent, and it respects the laws of physics, which is exactly what you need if you want to train a reliable AI. Okay, so how does this actually work in practice? It might sound super complex, but the workflow is surprisingly straightforward. So let's break it down. Let's look at how you actually get from a simple text prompt to a full-blown, ready-to-use dataset. First things first, let's talk about the basics of what you'll need. You've got two model sizes to choose from. And yeah, you're gonna need some serious hardware. We're talking a GPU with a lot of VRAM, or you can just rent one in the cloud. And here's a key piece of advice. Seriously, use the official Docker image. Trust me, it'll save you a world of pain trying to sort out driver and library compatibility issues. The workflow itself is really just 4 simple steps. Once you're all set up, you start writing your prompts. Now the real magic, the secret sauce, is in step 3. You can batch these prompts and randomize what's called the seed, which is basically just a starting number for the generation process. By doing that, you can create endless unique variations. And then you just hit go and let it generate thousands of images for you. And the scale we're talking about here is just incredible. Using this exact method, the folks behind the article we're looking at were able to generate over 6,000 unique, high-quality images for just one project. I mean, that's more than enough data to train a seriously robust object detection model. And it was all done automatically. All right, so we've solved the image generation problem. We have a folder that's just jam-packed with thousands of perfect pictures. But you know how it is. In solving one bottleneck, we've just uncovered the next one. And that's the big issue, right? We've automated creating the images, but now every single one of them needs to be labeled. And going back to drawing thousands of bounding boxes by hand, well, that would completely defeat the purpose of this entire awesome new workflow. The answer, and this is just beautiful, is more AI. Say hello to a tool called Grounding Dino. This thing is an open vocabulary object detection model. What that means is You don't even have to train it on your object. You just describe what you're looking for in plain English, and it goes in, finds it, and draws the bounding boxes for you. It is the absolute perfect partner for all our generated data. And the cool thing is, you have options here. There's an open source version you could download and run completely on your own machine, or if you need even better performance, you can tap into the more powerful commercial versions through an API. It's a really flexible system that can adapt to whatever your project needs. But hold on, we're not just talking about static images here. The next big step is video, because Cosmos Predict can also generate short clips. And that unlocks a whole new universe of training possibilities for AI. And there's a really practical tip here, based on real-world experience. For the best possible results, what you want to do is use the big 14 billion parameter model to generate your super high-quality starting images. Then you use the smaller 2 billion parameter model to turn those still images into short video clips. It's a little two-step workflow that apparently delivers fantastic results. So why does video data matter so much? Well, because the next massive frontier in this space is object tracking, especially for what's called edge AI. AI that's running on smaller devices, like a camera or a drone, not in some massive data center. Training models to track things that are moving is absolutely critical, and synthetic video is the key to being able to do that at scale. So there you have it. The bottleneck is broken. The tools to generate nearly infinite, perfectly tailored training data, they're not coming soon, they are here now. The only real limit at this point is our own imagination. So that leaves just one question, really. What will you build with it?